Plastic pollution is one of the most pressing environmental challenges over time. Traditional plastic can take hundreds of years to decompose, leading to massive accumulations of waste in landfills, oceans, and the environment in general. This is the reason that for our project we want to research if biodegradable plastics are an alternative for our reusable cups, which are mostly made out of polypropylene. Our reusable cups have a chance to land up in the environment with the cost of people accidentally forgetting them during a walk or at the beach. By making these cups from biodegradable material that are less intrusive on nature, the sustainability of reusable cups is increased.
The best substitute of PP for our reusable cup, we first need to think about the main properties we need to test for and what materials are suitable. After some research, two biodegradable materials stood out from the crowd. So the polylactic acid, most commonly known as PLA, and the polyhydroxybutyrate or PHP. PLA is a thermoplastic biodegradable polymer. The monomer is made of fermented plant starch such as corn or sugarcane. This material has interesting properties as it has a higher tensile modulus than the PP, but also a good thermal stability. On the other side, we've selected the PHP, a bio-based polymer which is also biodegradable, compostable, and biocompatible. This polymer is produced by microorganisms, and PHP has many advantages such as an easy manufacturing, good UV resistance, and is also hydrophobic, which makes a good applicant for our reusable cup. Let's imagine now some everyday life situation. So first, you are hanging out with some friends and suddenly your cup slips out of your hands and falls on the ground. So you need to have a material able to absorb the impact. If your cup is too fragile, it will break or crack. To characterize this property, we did a Nizod impact strength test. The test consists of hitting a notched sample with a hammer in order to break it. By measuring the height reached by the hammer after hitting the sample, we can calculate the absorbed and residual energy.
The results of the impact test show us that PP has a higher impact resistance than PLA and PHP. PLA has an impact resistance of 3.3 kilojoules per square meter and PHP has an impact resistance of 3.5 kilojoules per square meter. The value for PP is visibly higher at 8.1 kilojoule per square meter. As the impact resistance for PLA and PHP is therefore notably lower than the impact resistance of PP, further tests would be necessary to conclude whether the impact resistance of PLA and PHP is high enough to produce a durable cup out of the materials. Maybe additives can help to increase the impact resistance of the biopolymers to make them more durable.
Let's take another situation. It's Friday morning, fika time. You go and get a hot drink with your colleagues. Here, you need a cup that can keep its mechanical properties, such as rigidity and stiffness, and its shape, while holding a hot liquid. Let's imagine now that you get into a passionate discussion with one of your colleagues and forget about your drink, so the liquid stays 30 minutes in your cup. You need now a cup that doesn't absorb the liquid content and keeps the same properties as before. So for this, a water absorption test was carried out. The samples were set in a crystallizer filled with distilled water and left for 24 hours. We simulated two different environments, one at room temperature and one at 70 degrees Celsius to simulate a hot liquid in a cup. The weight difference before and after the experiment has been measured.
In general, we can see that the water absorption is lower at room temperature than at 70 degrees Celsius, and this is the case for all three materials. For PLA, the water absorption values are below 1% for both temperatures, but more important is that at 70 degrees Celsius, the sample deformed and changed from a clear color to a white appearance. PHP has the highest water absorption values for both temperatures. Especially at 70 degrees Celsius, it has a high value compared to the other materials, and therefore it would need further investigation to verify whether the absorption is still in an acceptable range or already impacting other properties of the material. For PP, we see low water absorption for both temperatures. The results indicate that PP is the best material to be used for drinking cups regarding the water absorption.
Moreover, as for any product, a good material is one that also meets the properties required by the manufacturing process. With reusable cups, that is done by injection molding. This process consists of heating pellets of polymers into a melting mixture, which is homogenized and pushed by a screw into a closed mold. After cooling down, the cup can be unmolded. So to be able to do so, the selected polymer needs to have a low viscosity so that the mixture can quickly fill the mold without voids. It is therefore important to estimate this viscosity value. So to do so, we use the capillary rheometer. This installation consists of melting polymer pellets and pushing them through a die thanks to a piston. It allows to get the relationship between the pressure drop of the flowing sample through the capillary and the sample flow rate.
Each capillary rheometer results are combined into a plot on which we can observe that all polymers have the same curve shape. Their apparent viscosity is decreasing while the speed piston and the apparent shear rate are increasing. On this plot, we can also observe that the PP is the polymer with the highest apparent viscosity. Then we have the PHB with a slightly lower viscosity. And the PLA has a much lower viscosity than the two others. During the test, we faced some issue. For the PP, we observed that the filament coming out had instabilities, showed by regulate waves. This should not impact the results, but it means that the parameters were not that well chosen. For the PLA, we observed some dripping, so the gravity could play a role in our results. This dripping shows that the PLA has a low viscosity. A polymer with a lower viscosity could be easier to inject during the injection molding. So the PLA could be the better option here.
Alright guys, so what is the conclusion?
For the capillary rheometer, I think that we could conclude that the PLA was the one with the lowest viscosity, so it kind of be easier to do the injection molding with it and more energy saving. But the PHB is closer to the PP, so it would be easier to set with like the usual and common settings for injection molding, and that would be with PHB.
Okay. For the impact tests, I think we can conclude that PHB and PLA are quite similar and have a definitely lower impact resistance than the PP. So that's something we have to keep in mind, and maybe that needs further testing, or we can think of any way to make the biodegradable polymers a bit stronger for an impact. So, yeah.
I mean, on an overview, our results show that the PP is still the best materials for reusable cup, but that's interesting because nowadays on the market it starts to where there are more and more PLA and PHB reusable cups. So
yeah, but I mean, like, I think there are also other aspects to take into account, like for example the price, which PP is the cheapest. And also the biodegradability. Like for PLA, it's not really biodegradable in nature, and it's like an industrial conditioning and everything. So you need to be careful because PLA can create like nanoplastic pollution if it's degraded into nature and not into industrial. So
that's definitely a good point, and we also have to look at our water absorption results, because there were some quite interesting results for the PLA because it actually deformed. So we had it in contact with 70-degree hot water, and it changed the form, and the PHB had a quite high, or compared to the others, a quite high water absorption, so we might need to look into that as well. So as you just said, PP was also the best for that.
I mean, to continue on the water absorption, maybe these results can have an influence on the mechanical properties at the end. So maybe to look further, it can be interesting to test again the materials after water absorption time.
Yeah, maybe for impact testing or something.
For example.
That would be interesting.
That would be interesting to continue with that.
Cheers.
No one told you life was gonna be this way. Your job's a joke you broke, your love life's the old way. It's like you're always stuck in second gear when it hasn't been your day.